Well, welcome to section 8.4 on slope-intercept form. We just went over the idea of slope in the previous section. We're going to use that to show us how we can help us to graph the solution sets of equations in two variables, or to graph lines. Alright, now what I'd like for you to do is I'd like for you to look at this line that I have graphed over here. As you can see, it's not very well drawn, but as you can see, it crosses the y-axis right here at the 1. This is called the y-intercept. Okay? And since I have a couple of points here that I can use, I can see that my rise over my run, my slope, is up to right 1, 2 over 1. That's a 2 there. And look at the equation that I have here. I want you to look at the 1 here and the 2 here. This is the slope, and this is the y value, the y-intercept. It crosses the y-axis right here at the 1. This point is 0, 1. The point itself is 0, 1. That's the y-intercept. So I can say that my slope here is 2, and that my y-intercept here is 1, or better yet, is 0, 1. Now, this is the proper answer, but you will see a lot of textbooks that only use the 1 as the y-intercept. I don't know why they feel that they have to write it that way, but they do. It's probably better off if you learn to write the y-intercept as an ordered pair. Same thing with the x-intercept. The x-intercept is not the key here. But you can see why this equation here is so important, because just by looking at it, I can identify the slope and I can identify the y value of the y-intercept. The way that this is written has a special name, and it is called slope-intercept form. So down here, a linear equation of the form y equals mx plus b. Remember, m is for slope, and in this case, b is for the y value of the y-intercept, is said to be in slope-intercept form. The slope is m, and the y-intercept is b, or as I prefer to write it, as 0b. You can tell that information just by looking at the equation of the line, as long as the equation is in slope-intercept form. Okay, now we're going to identify the slope and the y-intercept of the line with the given equation. Now if we graph these, we are going to get lines. We've done some graphing, but what we're going to do is, for right now, we're just going to identify the slope and the y-intercept. And if you look at the very first example here, example A, this is in slope-intercept form. Let me write it down again. Y equals mx plus b. You're going to need to know this one. See how it has y equals? See how it has y equals? That's a tip-off that you're going to have slope-intercept form. Then you have the x term, then you have a constant term. Well, this coefficient in front of the x, that's your slope. So my slope is 5. And in this case, my y-intercept, now notice the minus sign. The minus sign, remember that's the same as adding the opposite? Think of the minus sign as a negative. My b value here is negative 12. So I'm going to write the y-intercept, if I can get that erased, as 0, negative 12, because I like to write my y-intercepts as ordered pairs. Over here, you say, well, this isn't slope-intercept form. You've got y equals, that looks good, but there's no number in front of the x, just a negative sign. Well, what that means is the same as if there was a negative 1. Remember, it's understood that there's a 1 in front of the variable if there's no other number written down. If that negative sign wasn't there and it just said x, that would be slope 1. But in this case, my slope is negative 1 and my y-intercept is 0, 1. Now the third example is a little different because it doesn't have a constant term on the end. It just says y equals 4x. Well, that's pretty clear. That's your slope. M is 4. But since there's no number on the end, you can kind of think of it as plus 0 on the end. And my y-intercept would be the origin, 0, 0. B would be equal to 0. One more like this, and this one's already in slope-intercept form. Example D here, my slope is 3. You see it right there. You can see the slope-intercept form. And my y-intercept, again, minus sign right there, 0, negative 2. The last two examples are practically the same problem, even though they might not look that way. But they are equations that are not in slope-intercept form. So I'm going to write each one of these in slope-intercept form by solving for y. So these are going to take a little bit longer. These have some algebra to do before that. We have to simplify, solve for y. By the way, I have this one here with the axes only because I wanted to show you how simple it is to graph this line given this information. You graph the y-intercept down here at 0, negative 2. Remember, the y-intercept on the y-axis And then you use your slope to find a second point, because you need 2 points to graph a line. So I'm going to look at this slope in a fraction form as rise over run, 3 over 1. So from the y-intercept, up 1 spot, 2 spots, 3 spots, that's the rise, and the run is 1 to the right. So 1 to the right, and I put my second dot, and I'm freehanding it best I can. I'm going to graph the line itself. Just wanted to show you how easy that was. Now, the last 2 examples here, I'm going to find the slope in the y-intercept, but first I have to do a little bit of work here. I'm going to subtract 8x from both sides. I'm trying to get the y by itself. I get negative 3y. The minus is like a negative. Now here I have 2 minus 8x. Now those are not like terms, so don't try to combine them. And I'm not going to put 2 minus 8x because I want the x term first. So the minus here I'm going to write as negative 8x. And then, because it's a positive, 2 plus 2. Now I'm going to finish this off. I'm going to divide both sides by the number times the variable y here. I'm going to divide through by negative 3. Every term on both sides. Notice both terms. Y equals, I have a negative over a negative. That's a positive. I'm going to write that as 8/3 x, which is equivalent to having the variable in the numerator. This is the same thing. And then I have a positive 2 divided by a negative 3, that's negative 2/3, which I'm going to write as minus 2/3. So that I can see my slope is 8/3, and that my y-intercept is 0, negative 2/3. Now I'm going to do the same exact thing here with example F here. If you want to try this yourself, pause the instructional video, try it yourself, and then I'm going to work it on out. So I'll give you a second to pause. Okay, now I'm back. I'm going to go ahead and I'm going to subtract 4x from both sides. And minus, so it's negative 2y equals, I'm going to put this first, negative 4x plus 8. Didn't give myself very much space. Divide through here both sides, every term by negative 2. And I get y equals negative over negative again, that's positive. 4 divided by 2 is 2x. 8 divided by negative 2 is negative 4, so I'm going to write minus 4. My slope is 2, and my y-intercept, you see it here with the minus sign? 0, negative 4. Okay, let's try a couple more examples of this. Okay, we have a little story problem here that we're going to use SlopeIntercept Form on. It says Steve has $42 in his bank account, and each week deposits another $3. Write an equation that models his account's balance after X weeks, not after 1 week, 2 weeks, 3 weeks, after X weeks. So that's where we're going to get the equation here, and then we're going to use this equation to determine when he will have $120. All right, well, in this case, if you have X weeks, and he makes deposits $3 a week, that's 3x. $3 for every week. But on top of that, he already has $42 in his account. So that's his balance here, which I'm going to call y. Y equals 3x plus 42. You can see I have the equation. In slope-intercept form, my slope is 3, which is how much he's adding each week. That's how it's changing. My y-intercept is 42, 0, 42, because he starts out when x is 0, having $42. Now, how do we use this equation to determine when he has $120? Well, that's the balance here. $120, I plug in for y, and then I have a nice little simple equation. We've done these before. I'm going to solve for x to determine how many weeks. I'll subtract 42. And I have 8, looks like 78 equals 3x. I'm going to divide both sides by 3. And I have x is equal to 26, looks like. So it will take 26 weeks to save up that $120 at the rate he's doing this. Okay, one more very key idea about the equations of lines has to do with if lines are parallel or if lines are perpendicular. Now remember, slope describes how a line is slanted. So if you have parallel lines, remember parallel lines never intersect. They're slanted the same way. And two non-vertical parallel lines have the same slope. Now we say non-vertical because remember vertical lines, the slope is undefined, so you can't have same slope if it's undefined. All vertical lines are parallel to one another. All different vertical lines are parallel to one another, but two non-vertical parallel lines will have the same slope. Okay, that's key. And I've got an example here that I'm going to go over in just a second. And then also two non-vertical perpendicular lines. Now remember, perpendicular lines are lines that intersect and form right angles, 90-degree angles here. Two non-vertical again for the same reason because we're talking about slope and vertical lines don't have slope. two non-vertical perpendicular lines have slopes that are opposite reciprocals of each other. Now that's a lot. Opposite reciprocals. Opposite means the signs are different, and reciprocals, remember with fractions, is where you make the numerator the denominator and vice versa. So in this first example, I've drawn, not very well, but I've tried to draw two lines that are parallel to one another, and hopefully you can see they have the same slope. Look right here, up 1, over 1. This has slope 1. And look at the second line here, up 2, over 2. 2 over 2, which is 1, this has slope 1. So they have the same slope, they're parallel lines. Now over here, I've tried also to draw a couple of lines that hopefully will look perpendicular. They're supposed to be. It's supposed to be a right angle right there. That's the right angle symbol. If you look at the line that goes up and to the right, that has positive slope. The line that goes up and to the left, that's negative slope. So they have opposite signs for their slopes. For the positive slope, I tried to draw this so it looks like it goes up 1, to the right 2. Up 1, to the right 2. That would have slope positive 1/2. Whereas with the second line, I tried to draw this so that I would go from here up 2 to the left 1. Up 2 to the left 1, that's negative 2. These are opposite. You see they have opposite signs, and they are reciprocals of one another. You see how the numerator and the denominator are switched around. Perpendicular lines here. So what we're going to do, since we have slope-intercept form and we can identify slope, is we're going to also be able to determine what the slope of a line parallel to the given line or perpendicular to the given line. So that's what these examples are here, right here. For the line with a given equation, find the slope of a parallel line and find the slope of a perpendicular line. Well, this one is really, really nice because this is already in slope-intercept form. There's no number here on the end, but we said that's like plus 0. You can see my slope is negative 3. So parallel would have the same slope. It would be negative 3. Perpendicular, it would have the opposite, positive, and the reciprocal of 3, which is like 3 over 1, right? It would be positive 1/3. Now over here, this is also in slope-intercept form. You can see the slope is 1/4 and the y-intercept 0, 1. Parallel, they would have the same slope. It would be positive 1/4. Perpendicular, and I'm going to get lazy. I'm going to write an upside down capital T, which typically means it is perpendicular to, but that way I don't have to try to write it out again and possibly misspell it like I did the first time. I would need to take the reciprocal, which would be 4 over 1 or 4, but I would want the opposite reciprocal, so it would be negative 4 over 1 or just negative 4. Now the last example is not in slope-intercept form, although it will be an easy fix. I'm going to add x to both sides. And I have y equals, looks like 4 plus x, or better yet, x plus 4. Very nice because I do not have to divide. I have y already by itself on the left side. And there is no number in front of the x. Remember, that's like an understood 1. So the slope of this line is 1, and it has a y-intercept at 0, 4. So for parallel, I'll put it over here on the side. Parallel, it would have slope 1. It would have equal slopes. And for perpendicular, the opposite reciprocal, well, the reciprocal of 1 is 1, so the opposite of that would be negative 1. And that would be the slope of any line perpendicular to that given line there in example C. Now, this is important stuff, and as always, remember to practice, practice, practice.